Okay, so this is problem 3.8, and what it basically gives you is the potential energy function, and for part A you have to graph it out. So it's pretty easy. You just like plug in 0, then it will be 2, so that right there, and then 0.5 be 4 over 2.5, that's like 1.6, so it's right there, and then you just keep plugging them in. Oh yeah, well, that would be right there. Okay. So like that. That. Yeah. So it's gonna be a graph like that. And then for part B, determine the force associated with the potential energy. Okay, so force related to potential energy, it's actually the negative derivative for time, right? Or it's over the distance. Yeah, so it's all for that, right? Oh, and so you're given the potential energy function, so you just plug it in. It's really easy. So x, and then it's 4.0 over 2.0 plus x. And then that's, you take the derivative. So, well, oh my god. They use the, what do we call it? Damn it. Damn it. Pause or something. I can't think.
Yeah, you just take the derivative.
Yeah.
Yeah,
I'm
that's
trying to
awesome.
just make it more simple though.
Dude, they know how to take derivatives.
Okay, fine.
Don't worry, don't offend them.
Okay.
Sorry, viewers. Or viewer.
So the derivative will be this. So that's the force. So that's it for part B. Now part C, so you have to find the speed of the particle at x equals 2. So basically, use a work energy equation. So it's the change in potential energy equals 1/2 mv squared. So it's the potential energy equals the kinetic energy. Yes. So this is at x equals 2. So you want to look at the potential energy at 0 and also at 2. So you just look on your graph. So at 0 it's 2. So 2 minus, and then at x equals 2 it's 1. So 2 minus 1 equals 1/2. And then you can get they give you the mass, right? Do they? Yeah. Let's see that later. Okay. Yeah, so they give you mass. So you have everything there. You just find v. So it's just 1, 0.5. That's 1/4 v squared. 4. So 2. 2 equals v. Right. Yes. 2 equals v. So it's meters per second. So, and then part D, you need to select at least 2. Okay, so you need to select the equipment you need for an experiment. So to find the speed at x equals 2. So it depends on what you use for E. So the easiest thing to do is just use like distance over time. So you're given a track and a glider. So you can just use photo gates because they're on the list. So just use photo gate timer. Wait, stopwatch. Yeah, stopwatch. Because velocity equals distance over time. So stopwatch. Use one of those. Check mark. What else? Meter stick. Because you're going to measure the distance. Meter stick. So x equals 2 meters. So you want a photo gate like right before and like right after. And then you want to measure this distance, that would be D, and then you want to, the photo gates will automatically measure time, right? Oh, photo gate timer, that's what it is, okay. Photo gate timer. I guess you don't need that. So they'll automatically measure the time it takes to go in between those two when you turn on the photo gates. When the slider is going down with the force by the potential energy function. So then you'll find D and you'll get time. That's how you get V, and it should be 2.
Cut. Are you done?
Yep.